Hi, so for today we're going to talk about integrals yielding inverse hyperbolic functions. So we have here our formula for integrals yielding inverse hyperbolic functions, both for the inverse hyperbolic function and in terms of natural logarithm, because we can convert those inverse hyperbolic function into its natural logarithm. So we have several formulas. I think we have 5 formulas here for the inverse hyperbolic sine, inverse hyperbolic cosine, tangent, cotangent, secant, and cosecant. So let's get started. So first of all, for our first formula, okay, if we see an integral like this in this form, okay, we have the integral of du all over the square root of a squared plus u squared, where u is the um, expressed in terms of the variable here, okay, and a is any constant, so we can easily apply this formula. We'll be having inverse hyperbolic sine of u over a plus c. Okay, this is the equivalent inverse hyperbolic sine. Okay, or in natural logarithm, we can express that using the same definition for our a and u. So we have the natural logarithm of the quantity of u plus the square root of u squared plus a squared, which is basically the denominator here, expressed in a squared plus u squared, and then plus c. So that is for the inverse hyperbolic sine. And of course, we are also have the inverse hyperbolic for form for cosine. Okay, wherein we have the integral of du all over the square root of u squared minus a squared. That would yield to an inverse hyperbolic of cosine u over a plus c. Or in terms of natural logarithm, we have the ln natural logarithm of the quantity of u plus the square root of u squared minus a squared plus c, where u is greater than a. Okay? So for the arctan, I mean the inverse hyperbolic uh, tangent and cotangent. So we have du all over a squared minus u squared. So we have to familiarize ourselves at least in the denominator. So this could yield to two inverse hyperbolic functions, okay? Depending on the condition we have set here, okay, according to the given. So it could yield to either inverse hyperbolic tangent or inverse hyperbolic cotangent, okay? Given that if the absolute value of u is less than a, okay, the coefficient here in our u is less than a, the absolute value, we can use the inverse hyperbolic tan. And if it is greater than a, then we're going to use inverse hyperbolic cotangent. So if we are going to express this in the natural logarithm, we have only this formula. We have 1 over 2a ln of the absolute value of a plus u all over a. I mean, this should be a minus u. Let me just correct this, a minus u. The denominator should be a minus u. So the inverse, I mean 1 over 2a natural logarithm of the absolute value of a plus u all over a minus u plus c, where the absolute value of u should not equal to a. Okay, that is for the inverse hyperbolic tangent and cotangent. So how about for the secant or inverse hyperbolic secant? So we have du all over u square root of a squared minus u squared, and that is equivalent to negative 1 over a of the inverse hyperbolic secant, okay, absolute value of inverse hyperbolic secant u over a plus c. Or we can express this in terms of the natural logarithm. So we have negative 1 over a, okay, natural logarithm of the a plus square root of a squared minus u squared all over the absolute value of the u plus c, where we have the conditions here, u less than the uh, absolute value of 0, okay, where the value of the absolute value of u is in between 0 to a, 0 and a, okay? So the values of 0 and a. And lastly, we have the integral of the du all over u, okay, then square root of a squared plus u squared. So we have this formula, okay, and so forth. And that is also, we need to actually familiarize ourselves with this, okay, in order for us to solve. So in this video, I'll be glancing back on our formula for us to be able to recall, okay, the formulas. So we have the integral of dx all over square root of 4x squared minus 9. So how do we deal with that integral? So the very first thing that we're going to do is actually we know that if this would yield into an inverse hyperbolic function, we can rewrite this as we have 2x squared minus 3 squared. Okay? Again, we can rewrite this as this. So, if we are going to consider this, okay, as our u, okay, and this as our a, okay, so we're going to let u equals 2x, okay, and our a, by the way, is 3, not 9, okay? So, we get the derivative of u with respect to x, that is 2 dx. And we get this in terms of dx, so we have du all over 2, okay? And then we have dx. So what are we going to do here, okay, is simply, again, substitute these values on our integral. So what will happen? We have the integral now would be, okay, so we have dx, so we have du all over 2 all over, okay, the square root, okay, this is our u, so that must be u squared, and this is our a, so that must be a squared. So we can factor out 1/2 outside of the integral because du over 2 would be 1/2, okay? Integral of du all over square root, okay, of u squared minus a squared. Okay. So we have this, we can evaluate this integral. So if we are going to go back to our formula, okay, u squared, square root of u squared minus a squared is the inverse hyperbolic cosine. So, what are we going to do is simply integrate this. We have still the 1/2 multiplied by the integral of this. So, that would be, again, if I'm going to rewrite it, okay, so this integral will yield to inverse hyperbolic cosine of u over a plus c. That is the equivalent integral of this. So I can rewrite this inverse hyperbolic cosine of u all over a, okay, plus c. Okay. So if I'm going to distribute that, that would be 1/2 inverse hyperbolic cosine of u over a plus 1/2 times c. That is still a constant. And we're going to substitute it back, whatever the value of u, okay, of u and a. So what will happen here, this is not our final answer. We will be having 1/2 inverse hyperbolic cosine of the u. What is the u? That is 2x all over a, which is 3, okay, plus c. Now, this is our answer in terms of the inverse hyperbolic cosine. So we can also express this in terms, okay, of the natural logarithm. As I have said a while ago in our formula, okay, that this inverse hyperbolic cosine of u over a will be equal to ln of u, okay, plus the square root of u squared minus a squared plus c. So we can also express this in its natural logarithm. So, or, okay, I'll copy the 1/2 because this cosine equivalent has, inverse hyperbolic cosine has an equivalent. So that is 1/2 ln, okay, apply this in our formula, okay, applying this formula. So ln of u, what is our u? The u is 2x, okay, that is our u, plus we have the square root of u squared minus a squared, okay, the u squared, okay, our u, of course, is 2x. If we square this, so that is 4x squared, okay, and our a is 3. If we square this, that is 9. So simply 4x squared and 9, which is actually the denominator. So we have 4x squared minus 9 plus c. So these two are valid answers. So we can either express this in inverse hyperbolic cosine or in terms of the natural logarithm. So for number 2, let's go for number 2. That is the integral of dx all over the square root of 1 plus 9x squared. Okay? So what you're going to do again is to let u equals, rewrite this first. Okay? So for us to be able to see, so we have dx all over square root of 1 squared, that is still 1. So we have 3x squared. So we have to let u here, this would be our a, this would be our u. So our u would be 3x. Okay, our dx, okay, differentiate this. So this would be 3 dx. Okay, the value of our a here is 1. Okay, and expressing this in terms of dx would be du all over 3. And then we have dx. Okay, and then we simply substitute it. So if we substitute it, what will happen? So we have du all over 3 over, okay, square root, okay, that's 1 squared, that is a squared, plus our 3x, which is u squared. So again, we can factor out 1/3 outside of the integral sign so that we have du all over square root of a squared plus u squared. And if we are going to go back to our formula, okay, so this formula is in terms of hyperbolic sign. Okay? Inverse hyperbolic sign. So we can evaluate this as 1/3 inverse hyperbolic of sign. Okay? U over A plus C. But of course, we are going to substitute back the value of U and A. So we have 1/3 inverse hyperbolic sign of du. What is du? That is 3x all over the a, or 1 plus c. Or simply we have 1/3 inverse hyperbolic sign 3x plus c. So this would be our final answer for this problem in terms of the inverse hyperbolic sign. Okay? If we want to convert 1/3 inverse hyperbolic sign 3x, okay, into natural logarithm. So what did I tell you? From the formula above, we have inverse hyperbolic sign u all over a. That is equivalent to ln of u plus the square root of u squared plus a squared. Okay? This is squared plus c. Okay? So converting this, we have 1/3. We have to copy that. We have to multiply that to the equivalent inverse hyperbolic sign. So ln, okay, of u. What is the u? Our u is 3x here. So 3x plus the square root of u squared plus a squared, which is actually 1 plus 9x squared. So we have, it could be u squared. Our u squared would be 9x squared, okay, plus 1. Okay, plus C. Okay, so this should be our answer also. Both answers are actually valid. Okay, another problem for this. So we have number 3, integral of dx all over x. Then we have the square root of 1 plus 4x squared. So how do we do this formula? Okay, how do we solve this? Okay. So we can still rewrite this as the integral of dx all over x, then the square root of 1 squared plus 2x squared. Okay? So that we can let u equals 2x du with respect to x, derivative of u with respect to x would be 2 dx. Expressing that in terms of dx, okay, so we have du all over 2, we have dx. Okay? So, now we have to find a way, okay, to actually solve this also, the x. Okay? So, x, from this substitution, that would be x equals u all over 2. Okay, and now we are ready to substitute the values. So we have the integral of du or dx, which is du all over x. Our x is u over 2. Okay, and then we have defined this as our a, and this is our u also. So a squared, which is actually the 1, and then we have u here. So as you can see, the 2's will cancel. It will cancel. So we are left with the integral of du all over u. Okay? Then the square root of a squared plus u squared. Of which, this formula is actually the cosecant. Okay? So we have the inverse hyperbolic cosecant. So we have a squared plus u is squared. Okay? So we have negative 1 over a inverse hyperbolic cosine cosecant of the absolute value of u over a. So we can have this. This is equivalent to negative 1 over a inverse hyperbolic cosecant of the absolute value of u over a plus c. Okay? So we have to substitute. What's the value of a? Our a here is 1, obviously. So we have negative 1 over 1 inverse hyperbolic cosecant of the absolute value of u, which is 2x, all over the a, which is 1, plus c. And if we are going to simplify it, this would be negative inverse hyperbolic cosecant, okay, of the absolute value of 2x plus c. So this would be our final answer in terms of the inverse hyperbolic cosecant. Okay? So if we convert this into ln, okay, so we have the formula here, okay, negative 1 over a, okay, ln, let's copy that. So we have negative 1 over a ln natural logarithm of a plus we have a squared square root of a squared plus u squared all over the absolute value of u plus c. So we're going to convert this or transform this into natural logarithm. So we will be having negative 1 over 1. Our a is still 1. Then we have ln. Okay, so we have 1 plus a squared plus u squared. That is 1 plus 4x squared. Okay, this is squared all over the absolute value of u, which is 2x, okay, then plus c. So we'll be having an answer of negative ln of 1 plus square root of 1 plus 4x squared all over the absolute value of 2x plus c. So this would be our final answer for this problem. Okay, so in terms of inverse hyperbolic cosecant, okay, and in terms of the natural logarithm. Okay, so for number 4, let's try this problem. So we have the integral of dx all over, we have the square root of x squared plus 9. Let me just uh, rewrite. So we have, okay, so this is very obvious. We can rewrite this as the integral of dx all over, we have the x squared and we have the 3 squared. Okay, so we can let this as our u, okay, and we have this as our a. So we have the integral of dx all over, we have the square root of u squared plus a squared. So this is again inverse hyperbolic sign. So basically this would be what? So this would be uh our u here is x, our du is equivalent to dx only, so our a would be 3. So what are we going to do is simply substitute it with du, okay, integral of du all over square root of u squared plus a squared. Okay, so this is again the inverse hyperbolic sign of u or over a plus c. So we need to back substitute the value of u and a. So we have inverse hyperbolic sine of the u, which is the x, all over a, which is 3 plus c. So this would be our answer in terms of inverse hyperbolic sine. Or again, the inverse hyperbolic sine of u all over a is equivalent to the ln of u plus square root of u squared plus a squared, okay, plus c. So if we're going to convert the inverse hyperbolic sine of x over 3, okay, equals, that would be ln of the u, which is the x, plus square root of u squared plus a squared, that is x squared plus 9, okay, plus c. So this would be our answer in terms of the natural logarithm. Okay, for number 5. For number 5, we have to calculate the integral of dx all over 4 minus 9x squared. Okay, so the very first step we're going to do here is to rewrite this as dx all over 2 squared minus 3x squared. Okay, so that would be our simplification of that before we integrate that. Okay, so what are we going to do is to let, again, u equals 3x, and we have du, which is equal to getting the derivative of this as 3dx, and then we have du all over 3 equals dx. Okay, so we need to substitute. If we substitute it, so what are we going to do? We have du all over 3 all over, we have 2 squared, okay, minus 3x squared. So we can factor out 1/3 integral of du. So we can simply substitute a squared here minus the u squared here. Okay? So in this example, I will not be doing the inverse, but rather we're going to use the natural logarithm. Okay? So we know, class, that the integral of du all over a squared minus u squared from our formula above, okay, would be equal to 1 over 2a ln of the absolute value a plus u all over a minus u plus c. Okay? This is the logarithmic form, natural logarithm. Okay? So, here, we can simply integrate this. So, what will happen? The value of a here, okay, so we have 1/3 integral of du all over a squared minus u squared. That means we have 1/3 multiplied by 1 over 2a ln, natural logarithm of the absolute value of a plus u all over a minus u plus c. So, again, we need to identify the values of a and u. Again, the values of our a, value of our a here is 2. Okay, this is the a. Okay, and this is the u. Okay, so our value of a is 2. So what will happen? We have 1/3. We have 1 over 2 times 2 ln. Then we have a plus u ln of, natural logarithm of the absolute value of the a plus u. Our a is actually, again, it's 2. Okay, so we have 2 plus value of u 3x. Then we have a minus u 2 minus 3x plus c. Okay? So, we distribute 1/3. So, that becomes 2 times 2 is 1/4 times 1/3. That's 1 over 12. Okay? The natural logarithm of 2 plus 3x all over 2 minus 3x plus c. Okay? So, this would be our answer in terms of natural logarithm, because sometimes it's very confusing if it will yield to inverse hyperbolic tangent or a hyperbolic cotangent. So, we'd rather use the natural logarithm, okay, in order for us to really arrive at the correct answer. Okay? So, for number 6, we have the integral of dx all over the square root of x multiplied by 1 plus square root of 1 plus x. So in this problem, okay, so what are we going to do is to let u square root of x, because it's obvious, okay, here that we have a u times a square root of u plus a squared, u squared plus a squared. So we have to let u square root to x. Okay, so we have du. If we get the derivative of this, that would be simply 1 over 2 square root of x dx. By power rule, we express this in terms of uh, 1 half x raised to 1 half, then get the derivative. So we have 2 square root of x times du equals dx. Okay? Also, don't forget, okay, that we have to substitute again this. So what are we going to do is that is the integral. Okay, our dx is 2 square root of x du, okay, okay, all over square root of x, okay, multiplied by 1 plus x. So what we did is simply, okay, we substitute first, okay, the du. Of course, let us not forget, okay, to substitute this again, this one. So from this formula, we know that u squared is equal to x. Okay, so if we square both sides, so we can also say that is the integral of 2 square root of x du all over square root of x. I did not substitute u here because we can cancel it. So what will happen is that we have square root of 1, okay, squared. That would be our value of a, plus we have the what? U squared, okay, which is the value of x. So what will happen here is that this would be cancelled out, okay, so that we are left with, okay, we can actually factor out 2 outside of the integral sign. So we have du all over, we have a squared plus u squared, where our value of a is 1 and the value of our u, okay, or u squared is equal to x. Okay, so our value of u is square root of x, okay, here. So we can substitute this. This is simply the inverse hyperbolic sign. So we have uh, 2 sine inverse hyperbolic sign of u all over a plus c. So that would be 2 inverse hyperbolic sign of the value of u, and what is u? That is square root of x all over 1, which is a plus c. Okay, but then we can simplify it as 2 inverse hyperbolic of sine square root of x plus c in terms of the inverse hyperbolic. In terms of the ln, okay, we can rewrite this as, okay, so we have 2 ln, okay, of u, okay, we know that, but our value of u is square root of x plus square root of a squared x squared, or x squared plus a squared. Okay, our u squared plus a squared. Our u squared is the x. Okay, this is square root of u squared plus a squared. A squared is 1, so plus c. So this would be our answer in terms of logarithm. Okay, for number 7, let us try to solve the integral of dx all over 16x squared minus 9. So we can rewrite this as integral of dx all over 4x squared minus 3 squared. Okay? So we know that this would yield to an inverse hyperbolic tangent or cotangent. So, but to be sure, we can use actually the formula for the natural logarithm so that we have an answer that is only 1. Okay? So we will not be confused. Okay? So we have to have the value of our u as 4x, and of course our a is 3. Get the derivative of u, that is 4dx. So get dx, so that must be du all over 4, and we can substitute it. So that would be the integral of du all over 4 over, we have the u squared. Okay, I mean this should be written in this way: u squared minus a squared And we have to factor out 1/4 outside of the integral sign so that we have du all over u squared minus a squared. Take note that in our formula, okay, this is a squared minus u squared if we're going to go back. Okay, a squared minus u squared. So we have to force that to make it a squared minus u squared rather than u squared, okay, u squared minus a squared. So what am I going to do is simply, okay, I would go have a negative sign here, multiply it by negative 1, okay, so that I'll be having a squared minus u squared, okay. So this negative 1, I can factor it out outside of the integral sign, so this becomes negative 1/4, and then we have du all over a squared minus u squared. Okay, we simply apply properties here, so this one is still equal to this, okay. So what happens is that we can now use the formula. Okay, and then the formula of du all over a squared minus u squared. Okay, we know that from our previous example a while ago involving this. So we have 1 over 2a ln. Okay, 1 over 2a ln of the absolute value of a plus u all over a minus u plus c. Let me just double check it. Okay, a plus u all over a minus u, 1 over 2a. So we have still, don't forget the negative 1/4, okay, to be multiplied. So we have a negative 1/4 here, okay. So what will happen? We have negative 1 over 4 multiplied by 1 over 2 times a. The value of our a is again 3. Okay. Natural logarithm of the absolute value of a plus u. Okay. Our a plus u would be 3 plus 4x. Okay. Okay. And our a minus u would be a 3 minus 4x plus c. So we have to distribute negative 1 over 4. So we have negative 1 over 2 times 3 is 6. Negative 1/4 times 1 over 6 is negative 1 over 24. That's the natural logarithm of the 3 plus 4x, absolute value of 3 plus 4x, all over 3 minus 4x plus c. So this would be our answer for this problem. Last problem for this video. So we have number 8. Calculate the integral of dx all over 4x squared plus 12x plus 5. So what will we do, okay, if we encounter this type of integral, since we know that this will yield to an inverse hyperbolic, okay, that we can factor out 4, okay, outside of this. So we have x squared, okay, plus 3x. Since this don't have any x, okay, this 5 can be divided by 4. Okay, 5 over 4. Okay. So that if we distribute 4 here, okay, still 5 because 4 will cancel. So this is still equal to this. So we can actually factor out 1/4 outside of the integral sign. Okay. So we have x squared plus 3x plus 5 over 4. So what are we going to do is we can group this, okay, integral or the denominator as x squared plus 3x, okay, plus 5 over 4. And we're going to complete the square of this. So upon completing the square of that, okay, completing the square, so we divide 3x by 2. Okay, and that is 3 halves. And we square it. So that would be x squared plus 3x, okay, plus 3 halves square. We squared it, 3 halves, so 9 over 4. Okay? Plus 5 over 4. Of course, we have to subtract 9 over 4 here. So that this is still equal to our original polynomial. Okay? So we add 1/4 here, we subtract negative 9. We add 9 over 4 here, we subtract 9 over 4 here. Okay? So what are we going to do is 1/4 integral of dx all over, we can factor this since that is a perfect square, x plus 3 halves. squared. Okay? So we perform 5, 4 minus 9 over 4. Okay? So that would be minus 1. Okay? Because 5 minus 9, okay? We can subtract this numerator by numerator. So minus 1. Okay? So we can also square this because 1 squared is still 1. Okay? So let me just rewrite it clearly for you. We have 1/4 the integral of dx all over x plus 3 halves squared minus 1 squared. Okay? So we have the u and we have the a. Okay? But then, again, just like what we did from the previous problem, a should come first. So what are we going to do here is that we have 1/4. According to our formula, a should come first. So we have 1, okay, minus x plus 3 halves squared. Okay, this is squared also. But I have a negative outside this. Okay, so that this is still equal. So we compensated a negative. So we can factor out the negative so that it becomes negative 1/4. So that we have integral of dx all over we have 1 squared plus x plus 3 halves squared. Okay? So this is our a and this is our u. So we can use again the formula. Okay? We can convert this as, okay? So we have du all over a squared plus u squared. So there we have no problems because if we let u x plus 3 halves, okay, our du would be simply equal to dx. Okay? Okay? So, again, this formula yields us to we can use the natural logarithm. Okay? So, we have negative 1 over 4. Okay? Integral of du all over a squared plus u squared using the natural logarithm. So, we have negative 1 over, or if I'm not mistaken, that is 1 over 2a from our previous example. So that is 1 over 2a. 1 over 2a natural logarithm of a plus u, okay? Or over a minus u plus c, if I'm not mistaken. Okay? A plus u, a minus u. Okay? So don't forget, we have negative 1/4. We have negative 1/4 to be multiplied to 1 over 2 times a. The value of our a here is 1. So we have ln natural logarithm of the absolute value of a plus u. So we have 1 plus x plus 3 halves. And then we have a 1 minus x plus 3 halves. Okay, plus c. So if we simplify that, let me just rewrite it so that you can see it clearly. Okay, so that would be 1/2. Okay, negative 1 4 times 1/2 quantity ln. We have 1 plus x plus 3 halves all over 1 minus x. Okay, 1 minus quantity x plus 3 halves. Okay, plus c. Yeah. So, distribute, we have negative 1 over 8. Okay. So, if we distribute that, that would be negative 1 over 8. Then we have natural logarithm of the absolute value. 1 plus 3 half would be x plus 5 halves. Okay. All over, okay, all over, we have, okay, distribute the negative sign, negative x. So, this would be negative x. So, 1 minus 3 halves would be minus 1/2. So, plus c. So, this would be our answer. Negative 1 over 8, the natural logarithm of the absolute value of x plus 5 halves all over negative x minus 1/2 plus c. Again, if you like this video, thank you so much for listening. This is again Engineer Abat. If you like this video, don't forget to subscribe. Thank you.